let's take a look at other ways of expanding to remove bracket. If you check this, it says simplify the bracket of 3 plus x and another bracket 2 plus x. Now, these two terms can be classified as a binomial expansion. The reason is we have a term as 3 and another term as x separated by the addition sign in one bracket. Then 2 as a term and x also as another term separated by addition sign. And these two expressions are multiplying each other. Even though by appearance it remains as a single term in the bracket, it is still referred to as binomial expansion. To expand such a term, we can go through two different methods to solve or simplify this binomial expression. Now, let us start with the first method. This means that 3 plus x entirely is multiplying 2 plus x. That is to say, 3 has to multiply 2. 3 will still multiply x. Then the x will multiply 2 and x will multiply x, giving us an expression whereby the bracket will no longer be there. So let us do that one. 3 times 2 gives us 6. Then 3 times x gives us 3x, which is positive. Now we are done with the 3 in the first bracket. So we will go to x, still in the first bracket. Then x will multiply 2 in the second bracket, making it 2x, positive 2x. X will still multiply the x, making it x squared, positive x squared. At this stage, you will check for like terms, and automatically like terms has been grouped. 3x and 2x are like terms. They are not like terms with x squared because their powers are not the same. Even though they have the same variables, but their powers are different. So the only like term that we have will be 3x and 2x. 3x plus 2x will give us 5x. So we go write the whole thing as 6 plus 5x plus x squared. So finally, this will become our... Let's use another method to solve the same expansion question. Now, this method I have entitled it the seeding and the splitting method. So, since there are two different brackets, I will seed or maintain one of the brackets. So, 3 plus x multiplying 2 plus x. You can choose any of the brackets and maintain it. So, I'll choose the first bracket. You can also choose the second bracket. You get the same answer. So, from the first bracket, I have 3 plus x. Repeat the bracket you choose. So, the values in the bracket, the terms in the bracket, I repeat the same bracket, 3 plus x. Now the one you didn't choose, you rather split the terms and distribute them from the two seeded brackets. So 2 and plus x will be distributed. 2 to the first bracket and plus x to the second bracket. Now expand the first bracket with 2. So 2 times 3 is 6. Now 2 times x becoming positive 2x. Then we are done with that. Let's come to that of the positive x. Now positive x times 3 becomes positive 3x. Then positive x times positive x becoming positive x squared. Now we group like terms. I have 2x and 3x automatically grouped. So we will add. Before that, 6 will be there. Then positive 2x plus 3x will give us positive 5x. Then I have plus x squared. So at the end of the day, you are going to get the same answer as the first method. So the answer becomes 6 plus 5x plus x squared, since they are not like terms. Let's take a look at the second example, which says simplify into bracket 5m minus 1. Also another bracket m plus 2. As usual, this becomes a binomial expansion. let us use the first method to solve or simplify this question. Now, with the first method, we will use the first term in the first bracket to multiply the two terms in the second bracket. So 5m multiplying m gives us 5m squared. Still, 5m multiplying positive 2 gives us positive 10m. Now that we are done with the 5m, let's go to the next term, which is minus 1. So minus 1 times m will give us minus m. Then minus 1 times positive 2 gives us minus 2. Now that we are done expanding to remove the bracket, we will go ahead and check for like terms. And then the like terms in this expression will be 10m and minus m. Since they have already been grouped, let's simplify. So we have 5m squared beginning, then positive 10m minus m will give us positive 9m. Then finally minus 2. Now checking the final expression, we have no like terms to enable us to simplify. So then we'll leave our answer in the form 5m squared plus 9m minus 2. Wow. Let's take a look at the third example. It says simplify into bracket 3y minus 2 into bracket 2y minus 1. There is also another example of binomial expansion. Now we want to use the first method to expand this particular expression. Now, in the first bracket, we'll use the first term, which is 3y, to multiply 2y, giving us 6y squared. Then still 3y will multiply minus 1, giving us minus 3y. Now let's go to the second term in the first bracket, which is minus 2. It will multiply positive 2y, giving us minus 4y. Then finally, minus 2 will multiply minus 1, giving us positive 2. Automatically, there are like terms here and they have been grouped. So let's simplify. 6y squared. So 6y squared minus 3y minus 4y will give us minus 7y. Then plus 2. So since there are no like terms in the expression, we can conclude and make 6y squared minus 7y plus 2 our final answer. Let's take a look at example number 4. It says simplify into bracket 2 minus v all squared. Now let me clarify something here. Most students consider this expression as 2 squared v squared since there is a power outside the bracket, but that is wrong. This expression is referred to as a perfect square. What does it mean? This expression also means the terms in the bracket are multiplying themselves, which is to say 2 minus v, or multiplying 2 minus v. It will also not be plus because this is not difference of 2 squares. This is considered as a perfect square. The terms 2 minus v multiplying the same 2 minus v. So this is how you will do it. It comes back to the binomial expansion. So in this situation, we will expand using the first method. So 2 times 2 will give us 4. Then 2 times minus v will give us minus 2v. We'll go to the minus v, which will multiply 2, give us minus 2v. Then minus v times minus v giving us positive v squared. Now minus 2v are the like terms. So we'll simplify by grouping them. So 4 minus 2v will give us minus 4v. So minus 4v. Then plus v squared. Since the final expression has no like terms, then we'll consider 4 minus 4v plus v squared as our final answer for this particular question. Let's take a look at the fifth example under the binomial expansion. Now the question says simplify into bracket 2a minus b all squared. As we already said, this is a perfect square, so we have to express it as the bracket times itself. This way, 2a minus b all multiplying the same 2a minus b. Good. Then with this, we expand with the first method. So 2a times 2a will give me 4a squared. Then I have 2a times minus b, giving me minus 2ab. Then minus b times 2a will give me minus 2ab. And finally, minus b times minus b will give me positive b squared. Now, the like terms are minus 2ab and minus 2ab. So we'll simplify. You will get 4a squared minus 2ab minus 2ab will give us minus 4ab. So minus 4ab. Then plus b squared. Now, since we don't have any like terms in the expression, we will leave 4a squared minus 4ab plus b squared as our final answer. Let's now take a look at the question number 6, which says simplify negative 2 bracket of 4a plus 2, then another bracket a minus 1. If we take a look at this question, you realize that aside from the 2 brackets, there is still a term in front of the first bracket. In this case, you can solve this question in 2 separate ways. Let's see the first method. First method, you will use the negative 2 to expand the first bracket. Then the expression you will get, you'll still use the entire expression to multiply the second bracket. That is what I mean. Now, negative 2 times 4a will give us negative 8a. Then still negative 2 times positive 2 will give us negative 4. Then still in bracket multiplying a minus 1. So we will then use minus 8a minus 4 to expand a minus 1. So negative 8a times a will give us negative 8a squared. Then negative 8a times negative 1 will give us positive 8a. We come to that of the minus 4. Negative 4 times a will give us minus 4a. Then finally, negative 4 times negative 1 will give us positive 4. You go ahead and simplify since there are like terms in there. Minus 8a squared. Then positive 8a minus 4a will give us 4a. That is positive 4a. And finally, plus 4. Now, since this expression has no like terms, we can now leave our final answer in the form minus 8a squared plus 4a plus 4. With the same expression, let me use another method to solve the same expression. Now this time around, I will prefer to keep the negative 2, then I will expand the 2 brackets. When I'm finally done, then I will allow negative 2 to expand my final expression. This is what I mean. Keeping negative 2, then I will bring the square bracket so that it will allow me to expand this. Now 4a times a will give me 4a squared. Still 4a times minus 1 will give me minus 4a. Then I come to the 2. 2 times a will give me positive 2a. Then finally 2 times minus 1 will give me minus 2. I will simplify those in the square bracket and then I will multiply the final expression by negative 2. So that's what I mean. Minus 2, still with the square bracket, 4a squared. Minus 4a plus 2a will give me minus 2a. Then, because of the like terms, that's what I got, the minus 2a. Finally, minus 2. Then I'll continue. Since I have no like terms in the bracket, I will then expand the negative 2 against all the terms in the bracket. So negative 2 times 4a squared will give me negative 8a squared. Then negative 2 times negative 2a will give me positive 4a. Then finally, negative 2 times negative 2 will give me positive 4. So if you check the first method and compare it to this second method, their final answers are the same. So you can choose any of these two methods in case you come across a question like this. Let's take a look at question number 7, which says simplify 3 into bracket 2b minus 1 all squared. Do you remember this? 2b minus 1 all squared. Yes, the same thing you are thinking about. We call it the perfect square. So first of all, let's express it in its simplest form. It becomes 3 into bracket 2b minus 1 all bracket again 2b minus 1. So with this, it comes back to the fact that 3 is against the first bracket. I want to use the method where 3 multiplies the terms in the first bracket. Then the expression of the first bracket will then multiply all the terms in the second bracket. This is what I mean. 3 times 2b becomes 6b. Then 3 times minus 1 becomes minus 3. Put it in bracket since we are not done. Then repeat the second bracket as 2b minus 1. Let's go to the next stage where we expand the first bracket now by the second bracket. So we have 6b times 2b, making it 12b squared. There's still 6b times minus 1, making it minus 6b. We have negative 3 times 2b, giving us minus 6b. Then minus 3 times minus 1, making it positive 3. We have the like terms as minus 6b minus 6b. So 12b squared minus 12b. Since minus b minus 6b minus 6b is minus 12b. Then finally plus 3. There are no like terms in the final expression. So 12b squared minus 12b plus 3 becomes our final answer. Let's take a look at the 8th example. That's question number 8. Now simplify into bracket u plus v with another bracket u minus v plus in the bracket 2u plus v, then another bracket 2u minus v. As usual, if you check this particular expression, you realize that we have the binomial expansion around this area and still another binomial expansion in this area, separated by the addition sign. So let's solve them individually, then we come back to add according to the sign here. So we start with the first two brackets. Now u times u gives us u squared, the normal expansion. U times minus v gives us minus uv. We are done with the u. Now positive v times u becomes plus uv. Then positive v times minus v becomes minus v squared. This one belongs to the first bracket, so our plus must be repeated. Then we go to the next two brackets, which is 2u times 2u, making it 4u squared. Then still 2u times minus v, making it minus 2uv. Then we have v times 2u, giving us positive 2uv. Finally, v times minus v, making it minus v squared. Now let's simplify on both sides since there are like terms. So the like terms minus uv and plus uv will give us 0. So it becomes u squared minus uv and plus uv will cancel out. So we'll come back to minus v squared. Then the positive sign plus 4u squared. If you check this one, minus 2uv and plus 2uv will cancel out, giving us 0. So we have 4u squared minus v squared. Now, we can still group like terms. Let's continue here. Checking from here, it will be u squared with a like term of 4u squared. So we have u squared plus 4u squared. Then we have minus v squared with a like term of another minus v squared. Minus v squared minus v squared. Now, if you consider this, u squared plus 4u squared becomes 5u squared. Then minus v squared becomes minus 2v squared. Checking this expression, we realize that this will become our final answer. Now let's take the 9th question, which happens to be the final question for the binomial expansion of algebraic expressions. Now, if we check this particular question, just as we did in question number 8, we have the bracket of r minus s, also multiplying r plus s, minus 2r minus s, another bracket of 2r plus s. Watch this particular part of it. The negative sign is affecting this entire expansion. So we will separate the negative from the expansion, complete the expansion, simplify the expansion, then allow the negative sign to also expand so that you don't get the expansion wrongly done. Now this is what I mean. First of all, let's expand. So we will maintain r minus s and r plus s. Then separating it from the minus sign, we will also shield 2r minus s, 2r plus s. Why? So that the negative sign will not affect our expansion. When we are done with the complete expansion, we will not allow the negative sign to expand. So r times r here will give us r squared. Then r times positive s will give us plus rs. Then we have minus s times minus s times r, giving us minus sr. Then minus s times s, giving us minus s squared. Still in the first expansion. Then minus, let's look at the second expansion. 2r times 2r, giving me 4r squared. Then 2r times s, giving me positive 2rs. I have minus s times 2r, giving me minus 2rs. Then finally, minus s times s, giving me minus s squared in this bracket. Now let's simplify in the first bracket. Let me continue here. I am going to get r squared. Then rs minus rs gives me 0, so it will cancel out. So then I'll jump straight to minus s squared in the first bracket. Then minus the second bracket to have 4r squared. 4r squared. The positive of 2rs minus 2rs gives me 0. That is, it cancels out. So I'll jump straight to minus s squared. So minus s squared. Then I will expand with a negative sign to the second bracket, since there's negative 1 as a coefficient. So we have r squared minus s squared. Positive 1 leaves the bracket, expanding without changing the terms in the bracket. So I have minus 1 times 4r squared becoming minus 4r squared. The minus 1 times minus s becoming positive s squared. That is to say, minus 1 times minus s squared giving me positive s squared. Now group like terms. I have r squared here, r squared. The like term is minus 4r squared. They are like terms. Then I have minus s squared with a like term of positive s squared. Now, r squared minus 4r squared will give me minus 3r squared. Then minus s squared plus s squared gives me 0. So our final answer will be minus 3r squared.
Please subscribe to this channel and don't forget to click on the bell icon to be notified anytime we upload new videos. I hope you understood and enjoyed this video. Don't forget to leave a comment, like and share this video. Thank you and God bless you all.